Hello, my dear NEET warriors. Welcome, welcome, welcome. I hope you are ready to roar in this RNA series. Welcome aboard, my dear lions, my dear warriors. Get set, go with the first chapter of your NEET physics, which is also the 11th standards first chapter, units, dimensions, and errors. And you're going to study this with me on YouTube for absolutely free of cost in this RNA, which is Roar NEET Aspirant series. And in today's lecture, what and all we are going to do, I'll just brief you about it and I'll say hello. I want to meet all the new students out here as well. We're going to start off with physical quantities, the different two types of quantities. We're going to do the proper problems, concepts, everything for every particular topic. We are also going to talk about units after this. Then we are going to go to dimensions, and then we will see the applications and mixed problems as well. This will also contain NCERT questions. We'll also do PYQ questions. We'll also do conceptual questions. All kinds of questions from all the topics you will be seeing over here. Okay, so let's begin with the class. And this is my introduction. I want to meet all of you. Maybe you're watching it recorded, then you can put it up in the comments. Sir, this is future doctor so and so from Tamil Nadu. Sir, this is future doctor so and so, sir, from Maharashtra. I want to know all of you guys. Good evening, Savita, Sujal, Krishna, all the warrior Pandus have assembled. Hello, Redigiri. Hello, Pavitra. Hello, Satyashri. Hello, good evening, my dear lovely warriors. Let me also bring you guys up on the screen meanwhile. And as you're watching this video, nice to see all of you. Okay, meanwhile, this ad will keep playing, right? So we have all Rocky Bhais, all Pavitras, Lakshmi. Wow, too good, yeah, too good. Thank you so much. Thank you so much. Hello. And you're from the DNA batch. Wow, very good. So let me also tell you, these lectures will also serve another purpose. If you are planning to join the DNA batch, this will be like your backlog clearing session. You can watch these classes and immediately join the DNA batch. So your backlogs are also clear. So that's an additional advantage for all of you. And I'm not sure how many of you seen this particular link, which has been pinned on the chat box or even in the description box. That is a temporary link which will be there only for some time. So make sure you're checking it out. I'll tell you why. Because this link has all the resources for your NEET 2025 preparation, which we call as the NEET pedia, the syllabus, the mind maps, and the revision books. Also, predictor for your ranks versus college, the answer keys and the question papers of all the previous years, and also some additional mock tests. Please remember, NEETpedia will be available only temporarily for those early birds. After this will no longer be free of cost. So if you have not yet downloaded it, please download all these PDFs and all these links. The link is there in the description as well as in the pinned comments. Beautiful revision sheets, guys. Like for example, if I open up the chemistry, see all the chapters, all the formulas in one single PDF. It will be amazing only for all of you, right? So let's begin with full Josh, full energy. All right, in this RNA batch on YouTube. Let's begin, my dear students. Great. Sir, this is future doctor from Maharashtra, Dr. Gayatri Hansale. Wow. Hi, Captain America, says friends. Future doctor from Tamil Nadu. Wow, so cool, guys. So let's begin. Okay. Oh, by the way, I'm Shreyas. You can call me Captain Shreyas, sir, your captain of this particular ship of this RNA batch. And I have done my BTech from NIT Nagpur. I have done my BTech from NIT Nagpur in mechanical engineering, and also I did my research from IIT Bombay. And then I have been teaching for more than 12 years now, and I have also worked in the software industry before I started teaching. So I love teaching, I love physics, and I love making a below average student an above average student. I like to make an average student a topper. This is what I love to do. So hopefully you too will enjoy and follow and play along with me during this session and throughout the entire year. So do me a favor, smash the like button and subscribe to the Vedantu NEET English channel. Cool. So let's begin. So this chapter, my dear warriors, right, is going to be like an independent chapter. You will see a lot of concepts are there in this chapter which do not need too much knowledge of any other chapter. except for few parts where you might just need the formulas. We'll talk about it later on when it comes, but otherwise, fairly, it is an independent chapter, except for the formulas aspect. And you will see that this chapter is actually one of the easy chapters when the rotation monster will come later on in your 11th standard physics, right? Then you will be like, oh my god, sir, this is the monster, guys. Okay, this chapter of units and dimensions is not really the monster. So if you talk about the very first concept, which is nothing but what is a physical quantity? What is a physical quantity, my dear warriors? Physical quantity is something which can be measured. Yep, the class has just started, Shivani. Okay. Yeah. So Nikita will be taking up concepts. If a chapter is big, I will be dividing it into two parts. Like for today, we are doing units, dimensions. Another lecture, I will take vernier caliper, micrometer, screw gauge, significant figures, errors, all of that in one chapter. So we are going to divide in parts because I want everything to be taught in detail. That is the most important thing. You know, if you just, for the sake of it, a lot of people will try to do it in one shot. Okay, but a lot of concepts will be skipped. I don't want to do that. I want to make sure that everything is being taught in a proper manner. Even if we take 2 days, we still have time. Easily we'll be able to cover the syllabus, right? Okay. Yes, they will have numerical value. Like for example, this Pandu is standing over here. What is the height? Height can be measured. What is the length or distance between two cities? Or what is the mass of this rice bag? Or how much time have you been playing or watching this lecture? So these are quantities which can be measured. That's why they are called physical quantities. Whereas how excited you are can't be measured. How sad you are can't be measured. So they are not physical quantities. You can say, sir, my excitement level is 10. What is 10? 10 times of what? It's not possible to be measured like that. So they are not physical quantities. So let's see if you are able to apply this concept in this particular context over here in this conceptual problem. So whenever there is a separate problem type, I'll be mentioning it over here. If it is a PYQ, if it is an NCRT, or if it is a concept question, right? So all kinds of questions will be dealt with in these RNA series. Classify the following as physical quantity or not. What do you think? Come on, I want the spam in the chat box right away, right now. The fever of a human. This human being has a fever. He's suffering from dengue, malaria, something. Temperature of a hot Pandu. Champa's weight, Champa's beauty, my goodness. Pandu's running speed, and Pandu Champa's love. What do you think, guys? Which of the following are physical quantities or not? What do you think, guys? Okay. Fever of a human versus temperature. Temperature is measured Celsius, Fahrenheit. You can measure 98 degree Fahrenheit. Oh, no fever. 100 degree Fahrenheit. Oh, he has fever. 102, very hot Pandu. So Pandu is definitely suffering from something. So temperature is basically a physical quantity. Champa's weight. Never ever ask Champa's weight. You should not ask girls' weights, guys. You will get one tight slap. Okay. So that is always a secret. Remember that. So Champa's weight. Okay. For the sake of physics, Champa has agreed, but otherwise you should never ask Champa's weight. Is a physical quantity. Champa's beauty, no. Pandu's running speed, yes. Pandu is really quick. Fine. Pandu Champa's love, it can't be measured. It is infinite, guys. You can't measure it. And anyways, it is not a physical quantity. So this is not, and this is not. Everybody with me? B, C, and E. How many of you said B, C, E? B, C, E. Pratibha said that. Very good. Some of you went wrong about it. Very nice. Yes. Yes, Krishna. Very good. BC is a physical quantity. D is not a physical quantity. Correct. Perfect. Now you get it. Now, these physical quantities are further categorized into two categories. In another chapter, we'll categorize it as scalars and vectors. But today, we are going to categorize it as fundamental quantities and derived quantities. Fundamental quantities and derived quantities. Fever can be measured, understand, using Celsius and Fahrenheit. So what you are actually measuring is temperature. Fever. I have fever. I have 10 fever. No, I have 20 degrees Celsius. I have 50 degrees Celsius. That is measuring the temperature. So fever is just a saying, but temperature is a physical quantity. So don't get confused between fever and temperature. Okay, so they are two different things. Now, what is fundamental? Fundamental means what are we doing? Right from the fundamentals to advanced concepts, right from the basics to complex things. So this is like basic, this is like complex. Complex depends on the fundamental. Just like Only when you study addition, subtraction, multiplication, division in your 9th grade and 10th grade, you can solve quadratic equations, polynomials, surds, powers, so many other complex things. They are based on the fundamental, empirical, basic things. So that is exactly what quantities are defined as in fundamental and derived. So a fundamental quantity is one quantity where it is independent of others and it is like the most basic. Derived quantities depend on the fundamental quantities. Derived quantities, what will happen? They will be dependent. They will depend. They will depend on the fundamental quantities. For example, my dear warriors, for example, if I tell you speed, what is speed? Speed is nothing but distance divided by time. So speed depends on distance and time. Another example, if I tell you density, density, density is mass divided by volume. Okay, mass divided by volume. So now if I ask you, distance is distance a fundamental quantity? The answer is yes, it is a fundamental quantity. Is the time a fundamental quantity? The answer is yes. I can just measure time, I can just measure the distance, they are basic. But to measure speed, I will need distance and time. So hence this one is a derived quantity. Hence this one is basically a derived quantity. Next, if I ask you mass, is it fundamental? The answer is yes. I can just put the mass on something and I can measure how much does it weigh. I can definitely measure mass. It is a fundamental quantity. Volume, I can't measure directly. I have to measure something else like the radius or the side or something like that. So volume will depend on something else. Maybe the length, the height, the side, the radius, the height, so many different things it might depend on. So length is a fundamental quantity. Volume depends on those length dimensions. Hence, volume itself is a derived quantity. Not just that, even density is derived because it depends on two or more fundamental or derived quantities. Is that absolutely clear? A lot of people think volume is fundamental. No, volume depends on the length. Keep that in mind. So that is how you're supposed to think. So many examples are there like that. Can you guys quickly think and tell me about this particular example? What about, my dear warriors? What about momentum? What about momentum? Everybody might have heard this word momentum in 9th grade. Momentum, guys, what is it? It is nothing but mass multiplied by velocity. Mass multiplied by velocity. Mass is fundamental, but velocity is not fundamental. It depends on the displacement and the time. So hence it is derived. So is momentum also a derived quantity. Momentum is also a derived quantity. Very good. Finally, you guys got it. Understood? Okay. So, to summarize, there are more than just mass, length, and time in this universe, which are fundamental. There are more fundamental quantities. Scientists, who are the scientists? We don't know. Who are them? We don't care. Okay. But there were scientists who sat together and saw, okay, this depends on this. This depends on this. That time there was no reneat, dropping, nothing. So they had a lot of time in the world. So they thought, oh, these quantities, they are completely independent. Can I ever measure mass in terms of time? No. Can I measure time in terms of length? I want to measure how much time has gone. I will take a tape and I'll be like, let me measure the time. Can I measure time using length? Can I measure mass using time? No, right? So they are independent of each other. That's why they are fundamental. That's why they are basic. And there are 7 such fundamental quantities. 7 such fundamental quantities. What are those 7 fundamental quantities, my dear warriors? Well, can you guess it? Look at this. Kg means what? Mass. Second means time. Meters means length. Amperes means current. Kelvin, K, stands for temperature. CD, candela, is for intensity of the light, and mole is the amount of the substance. These are the 7 basic empirical fundamental quantities which are completely independent. They do not depend on anything else. Everything else in this universe depends on a combination of one or more of these quantities. Everything in this universe depends on combining one or more of these quantities, which are then termed as derived quantities. So, the fundamental quantities are length, mass, time, current, temperature, light intensity, and quantity. Okay, write it down again and again in your rough book, write it down in your sheet or maybe your notes, whatever it is. This should be there in your head. All the 7 fundamental quantities. Very good. But then, you know what? Some people realize, some cool people came, just like cool Shreyas Sir, and they were like, hey, these are not the only fundamental quantities. There are more fundamental quantities. They are like, okay, which are those more fundamental quantities? But there was something special about them. They discovered 2 more fundamental quantities, which has used throughout physics and mathematics and chemistry and everywhere else. What are those 2 extra physical quantities? Plane angle and solid angle. Plane angle and solid angle. So what is this plane angle and solid angle? Everybody knows plane angle. Plane angle is Shreyas Sir without goggles. Solid angle is Shreyas Sir with goggles. It can be a meme too, right? Solid angle is Shreyas Sir with goggles. It is some complex things. What is that? What is that, my dear warrior? See, plane angle is basically angle in 2 dimension. Solid angle is basically angle in 3 dimension, 3D. That's all. Plane angle is angle in 2D. Solid angle is angle in 3 dimension. You will be like, sir, what is it? How does it look like, sir? How does it look like, sir? How it looks like is like this. Normal angle, everybody knows. 2 lines you take, you measure this as the angle. 2 lines you take, you measure this as the angle. But solid angle, you cannot have just 2 lines. You need to have a surface. You need to have some kind of a surface. And that surface boundary, you trace it using a line. Like for example, over here, my dear warriors. Over here, check this out. You are tracing out this particular surface. You're tracing out this particular surface, which is there in 3 dimension, and whatever is subtended at a point, whatever is subtended at a point, like this thing over here, that is your solid angle. Just like in the previous sketch, this was subtended at that point O by this arc, by this arc, by this arc. So there was an arc which was subtending certain angle, and we all know arc is nothing but radius times the angle, radius times the angle. Here, when you have a surface, my dear warriors, when you have a surface, that particular area is nothing but radius square times the angle. That angle subtended could be given anything symbolically. Let's say I use the symbol sigma. Okay, I use the symbol sigma, rho, whatever you want to use, you can use. This is basically the solid angle. So angle into radius gives you arc length. Angle into radius square gives you the area. That angle is solid angle. Everybody got the difference? Everybody got the difference? Everyone? So this one over here is basically your solid angle. This is not your usual angle. It is solid angle. You can see it is in 3 dimension. It is in 3 dimension. This one over here is just your simple angle. This is your simple angle. That's the major difference. Everybody with me? Till this point, clear? Oh, cool. Shall we go ahead? Shall we go ahead, my dear warriors? Do let me know in the chat box. Awesome. Awesome. Very good. So keep this in mind. We'll talk about the units later on. So derived quantities, like I said before, they are dependent on other things like force depends on mass and acceleration. Acceleration depends on distance which you have traveled, time which you have taken and all of that. Velocity derived, heat derived, density derived, power derived, energy derived, acceleration derived, momentum derived, work derived, charge derived. Some of you get confused. Sir, how come charge is derived? I thought charge was fundamental. No, actually current is more fundamental. So what happens is you can see that oops, current, current is basically how much charge flows per unit time. So if you rearrange it, you will see the charge is basically the current multiplied by the time. Time is basically a fundamental quantity. Current is a fundamental quantity. So the charge is a derived quantity. So charge is basically a derived quantity. That's how it has been defined. Okay, very, very important. Cool. So there are many more fundamental and derived quantities. You will learn this throughout the year. You don't have to sit and by heart these tables which are there in multiple books. I have seen many students, especially 11th standard kids, get scared looking at, many tables, especially in the first chapter and looking at so many quantities. Sir, what is this quantity, sir? Torque. Sir, what is this stress, sir? I have so much of stress looking at this word only. What is this modulus? Sir, what is this coefficient of viscosity, sir? Don't worry. You will learn this throughout the year. You don't have to by heart this. All these things you will learn. Like in 9th and 10th, you will learn so many things. Throughout the year, you are going to learn. And that time, it will feel like a piece of cake. Just like, V is U plus AT, S is UT plus half AT square, force is mass into acceleration, basic things from your lower grades. Same way, you're going to learn all these things. Okay, cool, guys. So don't worry about these tables over here. Cool. So let's see if you guys can figure this out. Which of the following is not a fundamental quantity? Current, distance, heat, temperature. Okay, come on, my dear students. Come on, my dear students. Which of the following is not a fundamental quantity? Is not. Current is a fundamental. Distance is a fundamental. Heat is not. It depends on many things. Temperature is a fundamental quantity. You can measure it directly. Heat is the answer. Correct. C for Captain Shreyas. Very good, Krishna. Krishna gave the most appropriate answer. Whenever the option is C in anybody's class, Gopika ma'am's class, everybody's class, C for Captain Shreyas, D for your Diksha ma'am, B for your Baswa sir, A for amazing Gopika ma'am. Unfortunately, we do not have G alphabet, so we have put A for amazing Gopika ma'am. Cool. Okay. Let's see the next question. Which can't be a set of fundamental quantities in Pandu's system of unit? In Pandu's system of unit, Pandu is some new level genius. He has created his own world and he wants to create new fundamental quantities and other quantities will depend on it. So in Pandu's own world, what do you think can't be fundamental? Can't be fundamental. Think about it. Which can't be fundamental? Well, speed, time, distance, mass, time, distance. Guys, B option to 100% is, or rather it can be fundamental. Mass, time, length, definitely. Velocity, density, time. You might be thinking, sir, how will we measure length using this? Think about it. If I know speed, if I know time, I can measure distance. Correct? And if I know volume, and if I know density, I can measure mass. So mass can be measured, time can be measured, then length can be measured. So first option also possible. In fact, even in D option, time is there, length is there. From length, I can get volume. From volume, I can get mass using density. So even D option is possible. But C option is the problematic one. Speed, time, distance, no matter what you do, you can never ever get mass. Where is mass in any of these things? It is missing. So I think the incorrect option should be basically C for Captain Shreyas. Did I see C for Capto? C for Captain Shreyas, yes, which can't be a set of fundamental quantities in Pandu system. That is the correct answer. Correct. Option C. Very good. See, understand one very important thing. Who decided? Who decided distance is fundamental, time is fundamental, and then speed is basically derived quantity? Who decided? A set of scientists, right? But Pandu tomorrow can say, wait, speed is distance by time. I'll do one thing. Distance is basically speed multiplied by time. And for Pandu, speed is fundamental, time is fundamental, and he says distance is derived. Who is right? Who is wrong? Tell me. Who is right? Who is wrong? Both are right in their own way. Both are right in their own way. Don't say, sir, how can speed be fundamental? That is his own choice in his own set of world. In his new world, he has decided speed is fundamental. So even Pandu is correct. Remember that. But then you'll be like, sir, if everybody is correct like that, then I can make so many formulas, sir. I can make so many different formulas. Somebody will say, time is equal to distance by speed. So in this new system, distance is fundamental, speed is fundamental, whereas time becomes derived quantity. So who is right? Everybody is right, but then you need to always follow a set of rules if you have to live in the society. Just like, sir, why do we drive only on this side of the road, and why does the other side the traffic comes the opposite way? Why can't I drive this side and the traffic comes like this? There is no answer to that. It's just a historical reason. It's just been followed as a tradition. No, sir, we want equality. I should be equal. Everything should be equal, sir. I want to drive on both sides of the road. Very good. Please drive both sides of the road. So other people also say, I will also drive from both sides of the road. Very good. Everybody is equal. We have freedom to drive on both sides of the road. What will happen? You know. What will happen if this happens? Accidents will happen. That's why we have systems. That's why we have rules. You cannot say, I want freedom and I want to drive on both sides of the road. So why left side? No reason. You just follow it. How does it matter if it is left or right? Just follow it. So same way, distance and time have been assumed as fundamental, and automatically speed becomes derived. Is this thought process clear? Is this thought process clear, my dear warriors? Yes, Tina Saha, by filling the form, you can also get scholarship. Yep. Okay. Moving on to the next thing, which is units, which is basically units. Now, what is units? Units is basically whenever you have a physical quantity, you measure in terms of something. For example, let me give you an example, then you will be very, very clear. Say, I ask you, mass of, who is that student? Who can tell me their mass quickly? Somebody tell me their mass. Also, somebody tell me their height. Somebody tell me their height. Somebody tell me their height in centimeters and their mass in kg. Somebody tell me their mass in mass in kg and height in centimeters. Yep, come on. Somebody tell me their mass in kgs and height in basically centimeters. Who is that? Who is that person? I want to take somebody's name. Mass of Rocky. Mass of Rocky Bhai. Mass of Rocky Bhai. Rocky Bhai is 55 kg. Okay. And somebody else's height. Kamali. Height of Kamali. Height of Kamali is how much? How much height? 170 centimeters. Wow. Height of Kamali is 170 centimeters. Okay. So now, when I say mass of Rocky Bhai is 55 kg, this 55 is nothing but the value. This 170 centimeters, this 170 is value or basically magnitude. This is magnitude. This one over here, this kg, centimeter, that is basically unit. I know for sure what is 1 kg. So when I say 55 kg, it is basically 55 times of a standard kg. Everywhere in this universe, Everyone knows what is a kg in this world, actually, not universe. In this world, everybody knows what a kg is. Everybody knows what a centimeter is. And it does not change from America to Europe to India to some other place. Imagine some Pandu decided, Pandu said, my foot is basically one Pandu length, 1 PL. My foot, this is Pandu's feet, guys. So the Pandu is here, not showing that Pandu. Okay. Pandu said, my foot length is 1 Pandu length. So tomorrow Champa comes over here. Tomorrow Champa comes over here. Beautiful Champa. And Champa is like, what is my height? Champa is like, what is my height? So what Pandu does, he takes that 1 foot length and he sees, okay, how many such feet lengths come over here? He's like, okay, 4. So Champa's height, so Champa's height, so Champa's height is 4 Pandu lengths. Is 4 Pandu length. Wow, amazing. But then after some days, after few years, Pandu became even taller, his foot became even longer, and Pandu's feet became like this. So now this will become 1 Pandu length. So now the number of Pandu lengths might be just 3 or 2 or something. So then Champa's height will be 3 Pandu length. So has Champa's height reduced actually? No. Your basic fundamental unit has only changed. So you cannot have a unit which is changing with time or with place. Imagine you are going to some other country. You do not have Pandu's foot. You cannot call Pandu, can you parcel me your foot, Pandu? I want to measure the height of the building. Pandu will be like, what are you talking, man? Can you take somebody else's foot length? If you measure somebody else's foot length, gone. You will measure some other height only. So it has to be easily reproducible. It should be consistent. It can't change with time and it can't change with age. Whatever. Other factors should not affect it. That is the whole point, right? So, my dear students, whenever we take a unit, how should a unit be? How should basically our unit be? Yes, let me just put it over here. A unit, a unit, a unit should be easily reproducible. Reproducible, no matter where you go, it should be easily reproducible. You can, or basically can easily replicate it anywhere. You can replicate it anywhere. It should be constant. It should be constant with time. It should be constant with time and also place. Other external factors should not change it. External factors, external factors shouldn't change it. Shouldn't change it. Shouldn't basically change it. Then that is said to be a true unit. Otherwise, it will not be counted in the unit. Yep, correcto. Very good. So now that we understand what is a unit, okay, what is a unit over here. So do our fundamental quantities, okay, also have units? The answer is yes, we'll come to that. So in general, any physical quantity, let's say P, will be equal to the magnitude, sometimes you can also call it as the value represented by the symbol n times the unit, the unit symbol is u. So physical quantity is n times of u is a very, very important relationship. But also remember one more thing. Say for example, I measure Pandu's height to be 1.7 meters. In centimeters, it will be 170 centimeters. In millimeters, it will be 1700 millimeters. Now tell me, my dear lions, my dear warriors, which of the following quantities is more? 1700 millimeters or 170 centimeters or 1.7 meters? Or are they all equal? or are they all equal? Come on, my dear lads. Are they all equal? Or do you think, sir, 1700 millimeters, sir, very big. 1.7, very small. No, in fact, all of them are equal. So understand the unit also plays a role. Just looking at this 1.7, oh, my force applied is 7. I have applied 500 force. Like 500 force, 500 what? 500 Newton. Oh, it's huge. Understand that. So the units also plays an important role to understand how big or small it is. So a meter is a big unit, so the value went down. Millimeter is a very small, teeny mini unit, so the value became very, very large. In any case, what you are seeing is, if this is the value, this is the unit, this is the new value, this is the new unit, this is the value, this is the new unit, the unit changes, the value will change, but the physical quantity remains the same. So in general, the unit and the value or the magnitude are inversely proportional to each other. Are inversely proportional to each other. Is that absolutely clear, my dear warriors? Yes. Awesome. I hope you are understanding everything till here and you have smashed that like button. If you're understanding everything, smash it right away right now. Cool. So, having said this, there are other units also of length, let me tell you, but these are very, very large units. You might have heard of meters, kilometers, centimeters, feet, yard, miles, and all of that. But for very, very large distance, like the distance between the Earth and the pole star, distance between two galaxies and all of that, you have more units like astronomical unit is there, light year is there, parsec is there, etc. So what is astronomical unit? Astronomical unit is the distance between the sun and the earth. So let's say this is the sun. Let's say this is the sun. Okay, bright sun. Okay, this is your sun. This distance to the earth. This is your teeny mini earth. Let me show some green part, some vegetation over here. Okay, so this distance, whatever you are seeing over here, this distance from the earth to the sun is basically astronomical unit. Okay, one astronomical unit is close to 1.5 into 10 to the power 8 kilometers. 1.5 into 10 to the power 8 kilometers. The next unit which you have is light year, which you have is basically light year. Okay, so what is this light year? We'll talk about it also. What is this light year? So this was your one astronomical unit. What is light year? Light year is basically how far the light travels in 1 year. You wait for 1 year. You wait for 1 year. How far light will travel in 1 year? That is basically your light year. It is very huge, guys. Look at this, 9.5 almost into 10 to the power 12. Huge, because light travels at 3 lakh kilometers in 1 second. 3 lakh kilometers in just 1 second. So you can imagine in one whole year, it would have traveled so many kilometers. That is basically one light year. A lot of people think light year is a unit of time, but no, it is a unit of length or distance. Exactly. Awesome. Last one is one parsec. It is the distance at which one AU subtends an angle of 1 arc second, which is 1 by 360th of a degree. Now, everybody knows if you go one complete revolution, how many degrees are there? Come on, my dear warriors. If you go one complete revolution, how many degrees are there? Starting from 0 to like this, you will come back to 360 degrees. From 0, you go like this will become 180 degrees, this will be 90 degrees, this will be 270 degrees. So 1 degree is a very, very small angle. 1 degree is even a very small angle, correct? Very good. Is there an angle smaller than 1 degree? Yes, that is called arc second, which is 1 by 3600th of a degree. Imagine 1 by, you divide it into 3600 parts. I can't even do it on the board because my pen nib only is so thick. So imagine 1 by 3600th of it. 1 by 3600th of it, that is basically 1 arc second. It will be so small. So small. I can't even show it on the board, guys. It will be very small. So that is basically your arc second. Is that right? That will be a very small angle. Now imagine, to get that small angle, I have to go really far to make it look decent, so that the angle seen is very small. So I have to go really far. So if I see the sun and the earth very close, you can see the angle is more. As I go far, the angle becomes less. Correct? If I measure the angle here, it is more. If I measure the angle here, it is less. I go even far, the angle is even less. So I go really far. I go really far, where the angle subtended is 1 by 3000th of a degree, which is basically 1 arc second, So let's say that happens over here. Chumma, I'm giving some random point, but just to make you visualize. So if it happens over here, which is 1 arc second, all right, then that distance, this distance which you are seeing, is called as 1 parsec, That distance is called as 1 parsec. Have you now understood the difference between these three units? Did you now understand the difference between these three units? Maybe in your school or in your college or in your coaching, this was not taught, or taught by just by highlighting the definition. But I hope now it is conceptually entering your head. Astronomical unit, the actual distance between Earth and the Sun. 2 astronomical unit means 2 times the distance between Earth and Sun. 5 astronomical unit means 5 times of this distance, 5 times. Light year is the distance traveled by light in 1 year, which is very huge, 10 to the power 12. 1 parsec is that distance where Earth Sun subtend an angle of 1 by 3000th of a degree, which is very far. It's 10 to the power 13 kilometers. 10 to the power 13 kilometers. Keep that in mind. All right. So having learned this, what are the other units of mass, length, time, etc.? So let's learn that. So there are multiple systems. See guys, in India, we generally use a combination of CGS and MKS. A combination of MKS and FPS. Britishers have ruled us for quite some time, so their influence is still there in our education system and so many industries. So Britishers used to measure length in feet, mass in pound, and time, thankfully, in second for all the units. Whereas MKS, which is also called as the metric system, measures length in meter, mass in kilograms, and time in second. Then there is centimeter grams second system, where length is measured in centimeter, C for centimeter, mass is measured in gram, that is that G, and time is measured in seconds, so that is S. So metric, CGS, and foot pound system. Different parts of their world, depending on their history, geography, and their culture, they use different systems or combination of systems. But which is more widely accepted is basically MKS. But some people are very adamant, which is Britishers, they use FPS. No, I will measure the distance traveled in, feet, pound, and seconds, and all these things for mass, length, time, etc. So understand why it is not recommended to use FPS system is because the conversions and their values, etc., are very weird. See, I know 1000 meters is 1 kilometer. I know 100th of a meter is 1 centimeter. I know 1000th is 1 millimeter. So everything is in powers of 10, which is easy for calculations. Same thing with kilograms. 1000th of a kilogram is a gram. Correct? Quintal is 100 kg. Ton is 1000 kg and stuff like that. But it does not happen so in FPS. It's like 3 feet is or 12 inches is 1 foot, 3 feet is 1 yard, some yards are 1 mile. It's so weird. Where are these numbers coming from? 12, 3, random numbers. So that is why we generally do not prefer FPS system. Got it? Awesome. Awesome. Now that you understand what these systems are, now that you understand what these systems are, okay, and we are mainly going to use these MKS units. Your next question will be, sir, you just took length, mass, and time. Just some time back, you told me there are more fundamental quantities. In fact, there are 7 fundamental quantities. You just told me length, mass, time. Then there is electric current, thermodynamic, temperature, light intensity, and quantity. What is the unit of them? Well, the unit of them is as follows. Let me just show it to you over here. Yes, this is the unit. Length in meters, mass in kilograms, time in second, current in amperes, temperature in Kelvin, light intensity in candela, and quantity in mole. This is called SI system. So realize the difference between MKS and SI. MKS is only for meter, kilogram, and second. Only these 3 things are there. But when you add more things over here, then that same thing is called as SI system. System of units. It's a more widely accepted because it incorporates every single fundamental quantity. The short form of meter is M, small m. Remember, all units are in small letters except for this ampere and this Kelvin. So all these are in small letters. So kilogram kg, second S, ampere A, Kelvin K, candela CD, mole MOL. These are the short forms of this particular unit. Like I can say, the current in that circuit is 5 ampere, or I can just say it is 5 amperes like this. I can say the temperature of a body is 500 Kelvin, or I can just say in short form it is 500 small k. That is the meaning of that short form. Okay, so these are the fundamental units of those 7 fundamental quantities in SI system. But SI system literally takes care of everything. MKs only takes care of these 3 things. So our 2 other units which were there for angle and solid angle should also be considered in SI. So remember those extra quantities, supplementary quantities? Exactly. So plane angle is measured in radians, not in degrees. Solid angle is measured in sterdian, okay? That is having a short form of SR. So solid angle in sterdian and plane angle in radian. Okay, and I hope everybody knows what a radian is. We did the basics. So 1 radian, or rather I would say pi radians is basically 180 degrees. That is the conversion factor from degrees to radians. Sterdian is the unit of solid angle, short form SR. All right, very good, clear. Oh, thank you, Sushi, so much. Sush, oops, not Sushi. Yep, great. Ready, Gary? I hope you are clear with everything, SI and MKS. Okay. Now, I think we did how unit changes the numerical value over here, this particular part, right over here, N1 U1 is equal to N2 U2. But at this point of time, I also want you to understand the different prefixes which are, the different prefixes of the units which are used widely throughout physics and chemistry. So starting off with, say for example, whatever is your base unit, let's say base unit, whatever is your base unit, if you want to make it big, if you want to make that base unit big, you can add prefixes before it, something like this. Kilo, capital K is basically kilo. Then you can also add capital M, which is basically mega. Then you can also add G, which is basically giga. And then you can also add T, which is basically tera. You might have seen your hard disk size or your pen drive size or the memory size of your computer or the RAM size is also measured in this. The file size is KB, then some KBs make a MB, some MBs make a GB, some GBs make a TB, like that. Or your internet speed, KBPS, MBPS, GBPS, TBPS. So exactly the same thing. So kilo is basically 10 to the power 3. Mega is 10 to the power 6. Giga is 10 to the power 9. Tera is 10 to the power 12. 10 to the power 9, which is a giga, is also called as a billion. 10 to the power 6 m also is called as a million. This is also a million, and this is also called as a billion. You might have heard of millionaires. Billionaire, he's a millionaire, means he has 10 to the power 6 rupees or currency, whatever. He's a billionaire. That means he has 10 to the power 9, whatever, dollars, rupees, whatever. He is a trillionaire. This is also called as a trillion. This is also called as a trillion. That means he has 10 to the power 12 rupees, dollars in his bank. Understood the difference between million, billion, and trillion? It becomes big, 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 big like that on the top. Yep. Sir, where can we use solid angle? Kamli, you will be using solid angle in no case except for Gauss law. Okay, and that too in JEE Advanced. In NEET, you will not need it also. But still, I will be teaching you. Why? Who knows? NTMA might become mental and it might give some question, right? So we have to be prepared. So for that sake, I will just tell you about solid angle in Gauss's law only for that chapter sake. Otherwise, we don't need it. Okay, it's chumma given. Like intensity of light candela, you will not need it anywhere. It's chumma given. All right. Next important thing, if you go down, then instead of using capital symbols, you use small symbols. This is basically milli. Okay, this is milli, millimeter, milligram, like that. Then after that, you have this mu, which is called as micro. Then you have basically small n, which is called nano. Then you have this small p, which is called as pico. And then you have this small f, which is called as Fermi or femto. Fermi or femto, anything will do. So milli is basically 10 to the power, it's a smaller unit, minus 3. 10 to the power minus 3. I think I'll use a different pen. Okay, this is 10 to the power minus 3. This is micro. Micro is even smaller. It is 10 to the power minus 6. Nano is 10 to the power minus 9. Pico is 10 to the power minus 12. Fermi is 10 to the power minus 15. These are the prefixes which are used in different cases. For example, just for the sake of example, let me tell you, just for the sake of example, when I say this is having a length of 5 micrometer, it means it is 5 into 10 to the power minus 6 meters. Another example, the power of that engine, the power of that plant or that engine or whatever is 70 gigawatt, which means it is 70. Giga is basically 10 to the power 9, is basically 10 to the power 9. So 70 into 10 to the power 9 watts. That is what it means. When I say the mass of that object is, something like it is, let's say 68 milligram, or the dosage of the tablet is 68 milligram. It means it is 68. Milli is 10 to the power minus 3. So 10 to the power minus 3 grams. That is what it stands for. Understood? These are the prefixes. These are the prefixes which are used. Very good. Let's solve some questions based on this. Come on, my dear warriors. Can a physical quantity be unitless? Very interesting. If you answer this, I will be really proud of you. I'll be really proud of you. Come on. Can a physical quantity, this is a conceptual question like you can see, can a physical quantity be unitless? Come on, A or B? A or B? I want to see the spam. Everybody spam the chat box right away right now. Can a physical quantity be unitless? Think about it. Imagine there is a physical quantity. We generally write it as n into u. But can we write a physical quantity like this? Can we write a physical quantity like this, which is just n? There is no unit. There is no unit. What do you think? 100% this is possible. But is this possible or not? Is this possible or not? The answer to that is yes. Yep, it is possible, guys. It is possible. Like, for example, I'll tell you, example, refractive index of glass. When I say refractive index of glass is 1.5, there is no unit there. There is no unit there. It's just 1.5. That's it. Then another example you will see, coefficient of friction. Coefficient of friction between two surfaces. If I tell you it is 0.7, there is no unit over there. There is no unit over there. There are many more examples. You will see later on there is a term called as strain. The strain is, let's say, 70%. 70%, that's it. There is no unit over there. Okay. So many quantities are there which do not have unit. And you should be perfectly okay with it. Yes. Another quantity is basically specific gravity. Specific gravity. So specific gravity is basically how many times is it denser than water. If I say it is 13, there is no unit. Basically, it says it is 13 times heavier than water. It is the number. That's it. It's a factor. So there are many such quantities which do not have units. Okay. Yep. Very good. Awesome. Awesome. Next, a light year is a unit of ready, Gary, there is no time limit. Okay, this was asked in previous years. You can see PYQ. Light year is a unit of what? It is a unit of distance. Very good. It is a unit of distance. It is the distance traveled by light in 1 year. How much it travels? That is basically, the light year. A light traveling distance of something in 1 year is light year. Correct. It is the unit of distance. What is the SI unit of gravitational constant? Given the formula for gravitational force between two masses is G m1 m2 divided by r square. This is the formula. You have to find the unit, SI unit. This was also asked as a PYQ, guys. Okay, so this was also asked as PYQ. What will you do? Just if you know the formula, which you'll learn later on. If you don't know it, don't worry, I've given it to you. Just rearrange the terms and you will get it. See, using that formula, G will be force into R square divided by M1, M2. So when I have to find the unit, so the unit of G, I will first write unit of force. What is the unit of force? It is basically Newton. It is basically Newton. Force is measured in Newton. Distance is measured in meter. So this is meter and this is square. Mass is measured in kilograms. Mass is measured in kilograms. Mass is measured in kilograms. So hence it will be nothing but Newton meter square per kg square. That is the unit of gravitational constant. That is the unit of gravitational constant. Newton meter square per kg square. Correct. How many of you got it? Very good. So many of you got it. Perfect, 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 my dear warriors. Okay. Now let's come to the second part of the chapter, which is called dimensions. Okay, let's come to the second part, which is dimensions. Okay, remember we'll be doing errors and micrometer screw gauge in a separate session altogether. Okay, today's lecture is completely focused on what is units and what is dimensions. Now, dimensions by definition is nothing but the quantities, or if you take a physical quantity and you express it in terms of the fundamental, like mass, length, amperes, mole, etc. What will you raise the fundamental quantity to? And if you express it in terms of fundamental quantities, that is basically the dimension of a physical quantity. Let me explain this to you with a simple example. Say I tell you volume. I tell you volume. What is volume of a cube? It is basically length into breadth into height. If you look at length, breadth and height, at the end of the day, they are all dimensions of length. They are dimensionally length. Whether you measure length like this, or height like this, all length. Fundamentally, they are length. So can I say it is nothing but length whole raised to 3? Length basically whole raised to 3. But instead of writing LENGTH, which is very long, I can use a short form. I can use a symbol for it, which is basically L, which is, this is a base quantity. This is a symbol for that base quantity. And I can say it is L raised to 3. So when I say volumes dimension, dimension means you have to put square brackets. Square brackets, if it is there, you have to put, you are finding the dimensions. So the dimension of volume is length raised to 3. You have expressed it in terms of the base quantity. So realize this. Where is the base quantity? The base quantity is basically the length. The base quantity is basically the length. The powers or exponents is over here. This 3 is that power. That 3 over here is that power. So the dimensions, so guys, the dimensions of a physical quantity. So whenever I have to put dimensions, I will put square brackets. This is the physical quantity whose dimensions have to be found. So you express it in terms of the base quantities and raise it to suitable powers. That is the meaning of finding the dimensions. As simple as that. So I can give you many more examples where we are going to find the dimensions. Now, before we find the dimensions, let me go back and tell you the symbols for it. For all the fundamental quantities. I'll put it over here, fundamental quantities and their dimensions. So the dimension of length has a symbol L. Okay, so the dimension of length is having the symbol capital L. When I put square brackets, it means I'm finding dimension of it. So the dimensions, I'm going to put it over here. Dimensions, I'm going to put it over here. For mass, the symbol is capital M. For time, the symbol is capital T. For current, the symbol is capital A. For temperature, the symbol is capital K. For intensity of light, the symbol is capital C and then small d. Quantity of substance, the symbol is MO small and L also small, MOL. So these are the dimensions of these physical quantities. I can't use M because M has already been taken by mass. So even if I write MO, it can be confusing at times, like is it O or A, is it MA or what? That's why they have put MOL just for the sake of it. Okay, so L, M, T, A, K, C, D and MOL. These are the dimensions of all the fundamental quantities. Now I have a real question. What about plane angle and solid angle? What do you think are the dimensions of this? Remember, plane angle was angle in 2 dimensions. Solid angle was angle in 3 dimensions. So what is the dimension? What is the dimension of plane angle and solid angle? Yep, the correct answer is there are no dimensions for it. It is a dimensionless entity. It is a dimensionless entity, guys. Yep, no dimensions at all. Very good. Now, also keep in mind, a lot of students get confused between this dimension and 2 dimension and 3 dimension. Guys, let me tell you over here a very strict warning, not to be confused with 1 dimension, 2 dimensions, 3 dimensions, basically of our X, Y, Z. No, don't confuse with that. That is completely different. Those dimensions are for visualization. 1D means straight line, 2 dimensions mean plane, 3 dimensions means in anything in space. Those are different things. Here, the dimensions means completely different. Okay, in units and dimensions, it's base quantity raised to power. Base quantity raised to power. Okay, not to be confused. Okay, very important thing. Now, why is where is it? Why is your angle and solid angle dimensionless? Why is your angle and solid angle dimensionless? Remember, length was r into theta. Remember this? Length was r into theta. Length of the arc was r into theta. So if I take the dimensions of length of the arc, it will be the dimensions of the radius multiplied by the dimensions of theta. Length of the arc, length is having the dimensions of L. Radius is having again the dimensions of length. So what I have left with is theta. Length, do you see guys? They just get cancelled off. Hence, what am I left with? The dimensions of theta is nothing but dimensionless. There is nothing left over there. There is nothing left over there. Same thing happens even for solid angle. The area of the area which is there is nothing but r square into, let's say, your solid angle. So the dimensions of area is basically dimensions of r square into dimensions of solid angle. Area is length raised to 2. R square, R is length, so squaring it means again length raised to 2. So what do you see? Length square cancels, and you are getting a dimensionless entity over here. So hence both of them are having no dimensions. That is the proof for it. Got it, my dear warriors? Yep. Awesome. Vaishnavi, you have mock tests. Let me tell you, in the description box of all these videos, right over here, even in the chat box, there is a link which has been pinned. Just check this out link, or check out basically this link over here, which is there in the description box. All-in-one solution for your NEET preparation, which is called as your NEET pedia. Okay. So not only previous year papers are there, but also 8 mock test series and replica tests are also there attached for absolutely free of cost for a limited time. Okay, before this goes off, download this, give these tests, all right, for your benefit. Is that clear? Okay, perfect, perfect. Moving on, moving on. Let's find out the different dimensions of different quantities. Okay, let's find out the different dimensions of different quantities. So to find dimensions, so in order to find dimensions, there are two ways. One is by knowing the formula. The second one, the second way is by knowing the units of the physical quantity in terms of the base. What do I mean by that? Let me explain. Say for example, by knowing formulas, I want to find the dimension of velocity. I want to find the dimension of velocity. Let's see. Velocity formula, do I know? Yes, it is nothing but displacement divided by time. So I have to find the dimensions of displacement and time. Displacement is measured in terms of length. Correct? Displacement is measured in terms of length. Time is measured in terms of time. To write it in a much more standard form, you always put things on the top. So length is raised to 1, time is raised to -1. Suitable powers. Fundamental raised to suitable power. Fundamental raised to suitable power. So the dimension of velocity is L1 t raised to -1. Very good. Awesome. Awesome. Is that clear, my dear warriors? Very good. Guys, those of you who will disturb the class, they will get blocked. Keep that in mind. Yep. Okay, next one. What about the dimensions of acceleration? Well, acceleration is how much velocity will change upon the time. Velocity, I just found out the dimension formula is L raised to 1, t raised to -1, and time is again just t. Take it on the top, it will become t raised to -1 again. So hence the net dimension will become L raised to 1, t raised to -2. Because that time will go on the top, it will become negative power. So that is the dimension of acceleration. If you ask me what is the dimension of force, well, do I know the formula for force? Yes, it is mass times the acceleration. So the dimension of mass separately and dimension of acceleration separately. Mass's dimension is capital M. Acceleration, we just figured it out, L1 t raised to -2. So hence the net dimension will be M raised to 1, L raised to 1, t raised to -2. That is the dimensional formula for force. Very good. Awesome. Next important thing. Let's say I want to find the dimensions of work. I want to find the dimensions of work. Work, I know, is nothing but force multiplied by displacement. Dimensional formula for force, I just got it. M raised to 1, L raised to 1, T raised to -2. Dimensional formula for displacement is just length. So L1 will add, become L raised to 2. So M raised to 1, L raised to 2, T raised to minus 2. That is for work. Similarly, I want to find for power. I want to find for power. Power, I know formula wise is nothing but work that you do upon the time that you take. Work that you do upon the time that you take. Work, I just figured it out. M raised to 1, L raised to 2, T raised to minus 2. The whole thing divided by the time, which is basically T. So hence it will become M raised to 1, L raised to 2, T raised to minus 3. So this is how, using the formulas, you can find any dimension. If you know the formulas, you can find any dimension. Is that clear, everyone? We can do more problems. I want to find the dimension of charge. I want to find the dimension of charge. I'll tell you, charge formula is nothing but how much current flows into the time. So hence it will be nothing but ampere raised to 1, T raised to 1. That is the dimensional formula for charge. It's a derived quantity, mind it. Next, I want to find out the dimensional formula for heat. Heat, capital H you want to call it. Okay, how much heat will go? Heat, understand, is nothing but how much energy goes. Heat is nothing but the amount of the energy which is in transit. Energy dimensionally is the same as of work. Dimensionally is same as that of work. Okay, energy also you measure in joules, work also you measure in joules. I already found out the dimensions of work over here, m1 l2 t raised to minus 2. So directly put the same thing over here, m1 l2 t raised to minus 2. Is that simple, my dear warriors? Understood? Very good. Excellent. If you want the dimensions of pressure, if you want the dimensions of pressure, okay, the answer for that, well, it is force divided by area. Dimensions of force, m1, l1, t raised to minus 2. Dimension of area, L raised to 2. So what will happen? It will just become m raised to 1, L1 and L2. So it will become L raised to minus 1, T raised to minus 2. That is the answer for it. Correct. Same way you can find for many other things, guys, if you just know the formulas. Okay, it's just about knowing the formulas. Like, say, for example, one more thing, last thing I can give you is specific heat capacity. Specific heat capacity. Specific heat capacity, my dear warriors, is the amount of heat which is required per unit mass per change in the temperature. Heat we just figured out. Heat we just figured out, m raised to 1, L raised to 2, T raised to minus 2. Mass is nothing but m raised to 1. Temperature is nothing but measured in Kelvin. Hence, this will become just cancels out. So L raised to 2, then you have T raised to minus 2 and Kelvin raised to minus 1. That is the dimensional formula for heat capacity specific. Great. Perfect. Awesome. This is one way. What is the second way? By knowing the units, in fact, this is the most easiest way. This is the most easiest way. All right. Let's see. What is it? Oh, we have Pandu in the class. Pandu. Ayo. Pandu is Telugu Pandu. Oh, I thought our Pandu was Tamil Pandu. All right. So what is the second way? Second way is by knowing the units. How? Observe. Say, for example, the physical quantity which you know has the unit kg meter cube per second. That's it. It's enough for me to find the dimensions. What is kg measured in dimensionally? It is mass raised to 1. Meter is basically length. So length raised to 3. Second is basically time. So hence the dimensional formula will be m1 L cube T raised to minus 1. This is very, very easy. Very, very easy. Similarly, if I tell you the unit of something is ampere cube um, into kg square per Kelvin, okay, and I want to find the dimension of this. I want to find the dimension of this. You know, ampere is basically current, so A raised to 3, kg is mass, so m raised to 2, and divided by Kelvin, so it is basically K. So hence dimensionally it will become A raised to 3 m raised to 2, k raised to minus 1. That's very easy, especially if you know the units of it. Is that clear, everyone? Similarly, one more thing. Let's say it is Newton second per Newton second per joule. Newton second per joule. Okay, this is some unit, and I want to find the dimensions of it. What you will do is, you can first of all write down. Newton into second by joule. Newton, keep it as it is. Second also keep it as it is. What is a joule? A joule is a Newton into a meter. It is nothing but a Newton into a meter. Newton cancels. Newton cancels. You are left with seconds and meters. Seconds is basically time. Meters is basically length. So hence it will be L raised to minus 1, T raised to 1. That is the dimensions of that particular unit. Yep. Very good. Awesome. Clear? What is a unit? What is a dimension? Is the distinction clear? Everybody, shall we go ahead? Can we? We have found the dimensions using units. This part is done. Great. Now, tell me one thing before we go ahead. Can a physical quantity, okay, have the following? Have units, and this is, let's say, dimensions. Is it possible? Is it possible can a physical quantity have same units and same dimensions, different units but same dimensions, same units, different dimensions, different units and different dimensions? Okay, we'll try to analyze these things. Also, we'll try to understand, can a physical quantity, if it has unit, should it have dimension? If it has dimension, should it have unit? And all these things. So let's play around over here. I'm just going to create a, okay, later on we'll see this. Is it possible for a physical quantity to have unit as well as dimension? The answer to that is a big yes. Definitely. For example, we can take the example of force. So force has a unit, it also has dimension, definitely. Is it possible for a physical quantity to not have unit but have dimensions? Think about it. It does not have unit only, but it has some kind of dimension. Think, is it possible at all? This is basically not possible. Not possible at all. Imagine some quantity is there whose dimension is length, but it has no unit. How are you measuring it then? If it is measured in length, it will be measured in meters, centimeters, foot, something, right? So how can it be unitless? This is not possible. Is this possible? It does not have unit, but sorry, it has unit but no dimensions. This is possible, guys. This is definitely possible. Example, angle. Angle has a unit. Angle has a unit, right? But it does not have any kind of dimension. So this is definitely possible. Best example, angle and solid angle. Is it possible that there is some physical quantity? It does not have unit also. It does not have dimension also. It does not have unit also. It does not have dimensions also. Yes, even this is possible, guys. Best example, refractive index. What is the unit of refractive index? What is the unit of refractive index? Nothing. What is it dimensionally? Nothing. So this is also possible. Only this is not possible. Everyone got it? So a lot of you made a lot of mistakes, but after this problem, I'm pretty sure the difference between what is a unit and what is a dimension is there in your head. Is there in your head. Yep, very good. Now, what is the application of dimensions? Let's learn that. Okay, that is the last part of today's session. There are three major applications. First, to verify the correctness of an equation, which is also referred to as the principle of homogeneity. The principle of homogeneity. The principle of homogeneity. Second is to derive some kind of relationship between multiple physical quantities, which is very useful. Third one, converting units from one system to another system. The first application you will see, it is also useful in eliminating options. This particular process is also used to eliminate options in MCQ exam, in multiple choice question type of exam. So in fact, this is the most important thing. This is also very, very important. This is also useful in some formula based questions. Also useful. This is also useful to, select or eliminate options many times, to eliminate in MCQs, definitely. Third one is just useful in many problem solving. So let's see all the three applications. First one is verifying the correctness of an physical equation, which is also the principle of homogeneity. What is the meaning of homo? Homo means same. So principle of homogeneity means that it is having the same dimensions on both sides. Like for examples, say here, if I have two apples plus 3 apples, I will get 5 apples for sure. But if I take 2 apples plus 3 oranges, and if I say it is equal to 5 apples, you will break your head. You'll be like, what nonsense is this? This can't be possible. This is correct. You can add apples to apples. You can subtract apples with apples, but you can't add apples with oranges. This is exactly what I'm talking about. But you can multiply few things. Like say, for example, if I say there are 3 apples and each apple costs 10 rupees. Each apple will cost 10 rupees, right? I can multiply them. There is no harm in that. So I will get totally 30 rupees or whatever. So that is allowed. So principle of homogeneity means that whenever you put an equal to symbol, this side, whatever things are there, whether added, subtracted, here also, whether you add, subtract, no matter how many terms are there, each of the term has the same dimension. Each term has same dimension. Very, very important. Each term has the same dimensions. Only then it is said to be, a correct equation. Only then it is said to be a correct equation. Otherwise, the equation is not at all correct. Only then the equation is correct when the dimensions which are being added or subtracted are exactly the same. Such an equation is said to be dimensionally consistent. Dimensionally consistent, or basically correct. Let me give you an example for this. Over here. Say, if I tell you V is equal to U plus A into T. Some equation, maybe you do not know this. Let's pretend as if we do not know about this equation at all. Let's just act or pretend that we do not know anything about this. Okay. So now what I will do, I'll just find the dimensions of velocity. What is the dimensional formula for velocity? Come on, my dear warriors. It is length raised to 1, t raised to minus 1. Displacement per unit time. What is the dimensional formula for initial velocity? Well, that is also L raised to 1, t raised to minus 1. What is the dimensional formula for A into T? Each term separately I am finding the dimensions. Dimension of acceleration into dimension of time. Well, acceleration is nothing but L raised to 1, t raised to minus 2. Time is basically t. So hence, dimensionally this is L raised to 1. t raised to minus 1. Every term has the same dimension. Every term has the same dimension. Can you see that, my dear warriors? It is basically like saying L raised to 1 t raised to minus 1 is L raised to 1 t raised to minus 1 plus L raised to 1 t raised to minus 1. Every term has the same dimension. Hence, it is a correct equation. Hence, it is a correct equation. So this is said to be dimensionally correct. This is dimensionally definitely a correct equation. Do you guys understand it? Do you guys understand it? Dimensionally, it is a perfect equation, nothing wrong with it. Awesome. Okay, one more thing which people get confused. They think, sir, if I have length dimension plus length dimension, shouldn't it be 2L? Or some people think, sir, should it be L square? No, guys, it's not like x plus x is 2x. No, it is basically telling me this physical quantity is having a type of length. This is a type of length. So this side is not 2 times type of length. This side is also having a type of length. Got it? So length plus length is perfectly fine. Do not think it is the 2 times of L. Okay? But variables like x plus x plus x, they will become 3x. Do not say that is equal to x. That is not correct. Okay? This is variables, numbers. Okay? Or I can just say 2 plus 3 plus 4. Okay? 3 plus 4, 7. 7 plus 2, 9. This you can add and subtract. But dimensions don't add and subtract like this. That is wrong. Everyone with me? Clear? All right. All right. Now, let's see whether you guys can figure this bit out. If I give you an equation like this, V is equal to U 2U minus 3AT. Now, if you try to find the dimensions, each of the term which is being added or subtracted, V is having the dimensions of L raised to 1, T raised to minus 1. The dimensions of 2U, well, it will be dimension of 2 into dimension of U. 2 is a dimensionless quantity. U is basically length raised to 1, T raised to minus 1. So it is basically length raised to 1, T raised to minus 1 again. If you ask me the dimensions of 3AT, well, it is dimensions of 3 into dimensions of 80. Well, 3 is a dimensionless number. Acceleration is L raised to 1, T raised to minus 2. Time is basically T raised to 1. So it will become L raised to 1, T raised to minus 1 again. Now, if you notice again over here, this is length raised to 1, T raised to minus 1 is length raised to 1, T raised to minus 1 plus length raised to 1, T raised to minus 1. Is this dimensionally correct equation? Definitely. So this is basically dimensionally correct equation. Dimensionally correct equation. Nothing wrong. This is dimensionally correct equation. But I have a problem. But you know what? I have a problem. I have a feeling this equation is only wrong. In mathematics or in physics, we do not have V is U plus 380 or something like that. This is actually physically correct. So this has an additional criteria. This is basically mathematically correct. Mathematically, okay, mathematically, this is a correct equation. Or physically, this is a correct equation. Whereas this one over here is mathematically only incorrect. Or physically, it is incorrect. Mathematically incorrect. This is mathematically incorrect. Correct? My dear warriors, understood the difference? This is true dimensionally, but mathematically this is not true. V is not 2u minus 380. V is u plus 80. Another thing, what if I tell you, my dear students, V is equal to u square minus a by t or plus a by t. What about this? Check this out. V has a dimension of L raised to 1, T raised to minus 1. U square has a dimension of this whole thing raised to 2. So L raised to 2, T raised to minus 2. A by T has a dimension of acceleration is L1, T raised to minus 2. time is there below. So this will become L raised to 1 t raised to minus 3. 100% you can see none of the dimensions are matching. This, none of the dimensions are matching, unlike over here. Unlike over here. So 100% this is dimensionally incorrect. Dimensionally incorrect. Dimensionally incorrect. What can you tell about mathematically? What can you tell about mathematically, my dear warriors? 100% it will be mathematically also incorrect. So this is also mathematically incorrect. This is also mathematically incorrect. So what did you learn from these three examples? Can somebody put it up in the chat box? From these three examples, what did you learn? If an equation is dimensionally correct, then mathematically it may or may not be correct. Just because dimensions are matching does not mean it is mathematically correct. It may or may not be correct. But if dimensionally only it is not correct, then mathematically it is incorrect. Then mathematically it is incorrect. So I will put it up over here. If an equation is dimensionally correct, then it may be mathematically correct. Mathematically correct formula. Maybe. Very, very important. It may be or may not be also. But if an equation, is dimensionally incorrect, dimensionally wrong or incorrect, then it must be, there is a difference, maybe, must be, it must be mathematically wrong. It must be mathematically wrong. Very, very important. It must be mathematically wrong. Are these two sentences absolutely clear? Give me a thumbs up in the chat box quickly. Exactly. Yes, Satyashri, correct. Very good. Awesome. Awesome. So let's do some questions based on this. This was there in NCERT. I think you can easily guess this. Half mv square is equal to mgh. Check whether it is dimensionally correct or wrong. Well, if you see quickly LHS, if you quickly see LHS dimensions, which is basically half mv square, which is kinetic energy. Basically, kinetic energy is just like energy or work, is basically just like work. On the right hand side, what is it? It is basically mgh. Mgh is like potential energy. Dimensionally, it is same as that of work. So yes, both LHS and RHS, can you see, they have the same matching dimensions, same as like work. So hence, this is a correct equation. So this is a correct equation dimensionally. Is it dimensionally correct? The answer is yes. The answer is yes. Is that okay? Very, very straightforward. It is dimensionally correct. Shall we move ahead? Okay, fine. What about this question, guys? The SI unit of energy is joule, which is kg meter square per second square. Okay, which of the following formula for kinetic energy given below can you eliminate? Remember, just some time back I was telling you this particular method is used to eliminate options in MCQ. Let's say you are writing NEET 25 examination, and this is a very simple example, but just say for the sake of it, some formulas of energy have been given. M square V cube, half mv square ma, 3 by 16 mv square, half mv square plus ma. Which of the formulas will you eliminate? Which of the formulas will you eliminate? Check this out. First of all, half mv square is correct. Half mv square is correct. Even 3 by 16 mv square is dimensionally correct. Mathematically correct or wrong, that is not our worry. Dimensionally, B and D are 100% correct. Mass into acceleration, think about it, my dear warriors. The RHS is like force. Force and energy are not going to be ever matching with the dimensions. So force and kinetic energy, they will never ever match, guys. So that is wrong. This m square v cube, wrong. M square and v cube, how will it be kinetic energy? So this is also dimensionally wrong. This is also dimensionally wrong. What about this? Half mv square is there plus ma. This is kinetic energy, but this is like force. Mass into acceleration is like force. How can you add force with kinetic energy? This is also wrong. So automatically A option, C option, and E option got eliminated. Automatically A option, C option, and E option got eliminated. You can only choose between B and D. But out of B and D also, if you ask me mathematically who is correct, this is mathematically correct, whereas this one is mathematically incorrect. Okay, this is mathematically correct. This is mathematically incorrect. Understood, my dear warriors? Yep. Dimensionally, both are correct. Both B and D, dimensionally, both B and D, they are basically dimensionally correct. Dimensionally, they are correct. Very good. Awesome. Moving on to the next question coming up on your screen. S is, this is a previous year question. S is A plus BT plus CT square. The unit of C will be, what is the unit of C? Come on, my dear warriors. What is the unit of C in this particular thing? First of all, when you add or subtract and you put an equal to, the dimensions are same on both sides. So dimension of A is the same as dimension of BT, which is the same as dimension of CT square. So from this, what you can do, just take S and just take CT square and equate it. So dimensions of S is dimensions of C into dimensions of T square. What is S? S is basically measured in meters. That means it is dimensionally length. What is C? We don't know. What is T? It is seconds, so it is time. So T raised to 2. So what is the dimensional formula for C? It is basically L raised to 1, T raised to minus 2. That is the answer. So the unit of C, the dimensions of C will be L raised to 1, T raised to minus 2. So the unit of C will be, length is measured in meters, time is measured in second, meter per second square. Meter per second square. That is the answer. Is that clear? Very good. So if you know the unit, you can measure the dimension. If you know the dimension, you can get the unit also, vice versa. Can somebody tell me what will be the unit for B? What will be the unit for B and unit for A? Come on, think about it. The unit of B can be found by dimension of B. In fact, dimension of B into dimension of T will be the dimension of length. So B into T is a length. So B's dimension will be length raised to 1, T raised to minus 1, T raised to minus 1. That's it. So hence unit of B will be meter per second. Will be meter per second. As simple as that. Exactly. Very good. Keep it up. Moving on to the next one. The ratio of the dimensions of the Planck constant to the moment of inertia. This was asked in previous years, AIPMT 2005. Don't worry if you don't know the formulas. For Planck constant, I'll tell you, energy is equal to h into frequency is the formula. And frequency is 1 by time. Moment of inertia, the formula is m into r square. Just remember this. So let's use this information for our benefit. Let's use this information for our benefit. Okay. Ratio of the dimensions of the Planck constant and that of the moment of inertia. Planck's constant divided by the moment of inertia. Okay. So what is this going to be equal to? Just think about it. Planck's constant, h, is E by F. Is basically E divided by F. But 1 by frequency is nothing but time period. So it is into T. It is basically time, correct? Time is 1 by F. So 1 by F, I'll just put it as T. Rest of the things as it is, I'll put it over here. Moment of inertia, the formula is m into r square. m into r square. So I'll just keep m into r square right over here as it is. I will not change anything over here. Now, let me put dimensions of every single term which is there over here. I hope till this point everything is clear. So what will be the dimensions of this? What will be basically the dimension of h by I? What will be the dimensions of h, Planck's constant divided by moment of inertia? Dimensions of it will be basically E into dimensions of T divided by dimensions of M into dimensions of R square. Energy is having the dimensions of m raised to 1, L raised to 2, T raised to minus 2. This is time, so T raised to 1. Whole thing divided by. This is mass, so m raised to 1. This is distance, so L raised to 2. So many terms are getting cancelled, like m raised to 1, m raised to 1, L raised to 2, L raised to 2. So what is it becoming then? Just check it out. It is just coming out to be t raised to minus 1. This is just like 1 by time. 1 by time is same dimensionally as frequency, is the same dimensionally as frequency, which is 1 by time. So I think I can see frequency over here. Hence, that is the answer. Hence, that is the answer. Is that absolutely clear? So if you know the formulas, immediately you can solve these kind of questions, no matter which PYQ it is. Very good, Avisha. No, it is not D for botany. It's D for doctor. D for Diksha ma'am. Yes, Pratibha. Correct. Yes. Pandu, please talk in English, man. Don't change the language. Dr. Shruti Blessy, Naku time kuda ledu. Oh, for all these things, you don't have time. For studies, I hope you have time, Shruti Blessy. Clear, Capto? Okay, great. Moving on to the next questions. So the next application is converting the units of a physical quantity of one system to the another. One system to the another. Okay. So this is very simple. I'll just show it to you in a very simple manner. Okay. In fact, let me tell you, if you have N1, U1 in one unit, it will be N2, U2 in another unit. This is one way of doing the problems, but most of the times I'll be doing the questions in a slightly different way. You will check what is each unit in terms of the other unit. So if you know the dimensions, this is method number 1. Method number 2 is, if dimensions are known, if dimensions are known, find conversion for each dimension and then substitute. What do I mean by this? I'll tell you. This is generally not so useful. Use this method, which is very, very useful. Let's take the example to convert force and work units from SI system to CGS system. Let's start with first force. Do I know the dimensions of force? What is the dimensions of force? Come on, my dear warriors. It is mass into acceleration. So m, acceleration is meter per second square. So length raised to 1, t raised to minus 2, kg meter per second square. Once you know this, then your job becomes easy. So let's say I start off with one SI unit of force. How much is it? You take mass in kgs, so that will be kg, length in meters, so meters, time in seconds, so s raised to minus 2. Use this dimensional formula to substitute everything. Use this dimensional formula to substitute everything. Now you think each unit, what is it in the other unit, other system? Find the conversion for each dimension. Find the conversion for each dimension. 1 kg is basically 10 to the power 3 grams. 1 meter is basically 10 to the power 2 centimeters. 1 second is 1 second only. So it is second raised to minus 2. in the other unit. Just take care of the numbers. 10 raised to 3, 10 to the power 2. It will just become 10 to the power 5 gram centimeter per second square. What is this? This is your CGS unit. So this is basically 10 to the power 5 CGS unit. That's all. So N1 U1 is N2 U2. We got it, but in different units. In fact, you will see that one unit of force in SI system is actually called Newton, whereas in CGS it is called dyne. So 10 to the power 5 dynes. 10 to the power 5 dynes. That is how it works. Did you understand what we just did? If you know the dimensions, substitute the units for the corresponding dimensions and know the conversion factor for each dimension, for length, for mass, for time, etc. Substitute, you get the answer. Very straightforward. Very straightforward. Let's try it out for work. For work, what is the dimensional formula for work? It is m raised to 1, l raised to 2, t raised to minus 2. If you know the dimensions, you can easily do this problem also. So, one SI unit, one SI unit of work, how much will it be? Mass raised to 1, so kg. Length raised to 2, so meter square. Time raised to minus 2, s raised to minus 2. 1 kg is 10 to the power 3 grams. 1 meter is 10 to the power 2 centimeter, but square it because this is squared. Second is second only, so 1 second square. Okay, so what will this become? 10 raised to 2 raised to 2 is 10 to the power 4 plus 3 is 10 to the power 7 gram centimeter square per second square. What is this? This is your CGS unit. This is basically your CGS unit. Exactly. So, one SI unit of work is called as 1 joule. So, 1 joule is basically 10 to the power 7 ergs. Is basically 10 to the power 7 ergs, which is the CGS unit of work. This is how this has to be done. Clear? Shall we go ahead? Everybody? Ready? Let's move. Let's move, guys. Let's move. Okay, let's start with the question coming up on your screen. Filling the blanks. Okay, the volume of a cube, this is NCERT based, volume of a cube of side 1 centimeter is equal to how many meter cube? First question, very straightforward. Let's do this. First question, guys, let's do this. 1 centimeter is the side length. So what is the volume? Volume is basically side length, whatever is there. You have to basically take the side and cube it. Okay, what is the side length? The side length is 1 centimeter. So 1 centimeter cube. But remember, I want to give the answer in terms of meter. So 1 centimeter is how many meters? 10 to the power minus 2 meters. So hence the final answer for this will be 10 to the power minus 6 meter cube. So the volume is 10 to the power minus 6 meter cube. We did the first question. Absolutely clear, my dear warriors? Understood? Can we go to the next question? Surface area of a solid cylinder of radius 2 centimeter and length 10 centimeters equals to how many millimeters? So let's go to the second one. The surface area of a cylinder is 2 pi r into length. 2 pi r into length. So what is the radius? Radius is 2 centimeter. Radius is 2 centimeter. What is the length? Length is basically 10 centimeters. But I have to give the answer in millimeters. We have to give the answer in millimeters. So be careful. 1 centimeter is 10 millimeters. So 2 centimeters will be 20 millimeters. 10 centimeters will be basically into 10. So into 10 is 100 millimeters. So what will this become, guys? What will this become? 2 twos are 4. 4 is there and 3 zeros are there. So this will become 4,000 pi millimeter square. 4,000 pi millimeter square. Is that clear? Everybody got it? This is the second answer. You can convert it into decimals to fill in the blanks properly. Next one. A vehicle moving with a speed of 18 kilometers per hour moves how many meters per second? Very interesting. So guys, 18 kilometers per hour. What is a kilometer? It is basically 1000 meter. What is 1 hour in seconds? It is 3600 seconds, or basically it is 60 minutes. Each minute is 60 seconds. So it is 3600 seconds. 0 cancels. 0 cancels. 18 goes with 36. How many times? 2 times. So 10. 18 goes with 36 2 times. So how much will this be? It will be 5. But this is meters per second. Do not forget that everywhere it is meter per second. So it is basically 5 meters per second. So 18 kilometers per hour is 5 meters in 1 second. So that is the answer for the third question. That is the answer for the third question. Let's move on to the next question, guys, coming up on your screen. What is it? Relative density of lead is 11.3. Density in gram per centimeter or kg per meter cube. Actually, when I say relative density is 11.3, it is 11.3 times heavier than water. So density of water is 10 to the power 3 kg per meter cube. This is a standard thing. So hence the actual density of lead, will be 11.3 kg per meter cube. This is in kg per meter cube for lead, but I have to multiply it with 10 to the power 3 because that is the density of water. 11.3 into 10 to the power 3 kg per meter. That is in kg per meter cube. Correct? But we cannot stop there because they also asked for gram per centimeter cube. No issues. It will be 11.3 into 10 to the power 3 kg. 1 kg is 10 to the power 3 grams. A meter is 10 to the power 2 centimeters. And then put cube over here. See what will happen. 10 to the power 2 raised to 3 is 10 to the power 6. 10 to the power 3 into 10 to the power 3 is also 10 to the power 6. They cancel, and what is left? 11.6 into 10 to the power 6 on the top, 10 to the power 6 on the top, gram per centimeter cube. It will just be 11.6 gram per centimeter cube. So we got the answer in gram per centimeter cube and also kg per meter cube. This is your NCERT question. Clear? Everyone? Understood? If you understand these problems, any other conversion will also become easy. In Champa's system of unit, length is 10 meter, time is 100 seconds, mass is 20 kg. Then the force of 20 kg per kg meter per second square is how much in her units? Okay, let's try to do this problem. In Champa's system, length is 10 meters. One Champa length is 10 meters. Therefore, 1 meter will be how much Champa length? 10 meters is 1 Champa length. 1 meter will be 1/10 of Champa's length, whatever her unit is. Similarly, 100 seconds is the unit of time. So 1 Champa time is 100 seconds. Therefore, 1 second, take the reciprocal, it will be 1/100th of a second. 1 Champa mass is 20 kg. So 1 Champa mass is 20 kg. So think about it. 1 kg will be 1 by 20 Champa mass. 1 by 20 Champa mass. Right? Very good. So now let's do the final conversion. What is it asked? 20 kg meter per second square. 20 is as it is. Take a look at kg. 1 kg is 1 by 20 Champa mass. So 1 by 20 Champa's mass. Okay. Meter. Where is a meter? It is over here. 1 meter is 1 by 10th. 1 by 10 of Champa's length. Great. Whole thing divided by second square. 1 second is 1 by 100. So this will be 1 by 100 of 1 by 100 of Champa's time unit CT, and this is basically whole square. As simple as that. Now just play around with the numbers. Just play around with the numbers. This 20 and this 20 cancelled. This 100 is squared, goes on the top. It will become 100 square. This 10 just remains as it is. This 20 and this 20 cancels out. So you have Champa mass into Champa length, whole thing divided by Champa time, whole square. So what is this? 20, 20 cancels, 1, 0 cancels. It will become 10 to the power 3 Champa unit of force. So this much is 1000 Champa force. This much is 1000 Champa force. 10 to the power 3 Champa force. Got it? Understood? Everyone? Very good. Excellent. Awesome. Awesome. Let's see if you can solve this PYQ. Length and force is increased 4 times. What will happen to the unit of energy? Length and force unit is increased 4 times. What will happen to the unit of energy? Is energy somehow related to force and length? Yes, think about it. Energy is having the same unit as that of work, and work is nothing but force multiplied by the displacement. And displacement is nothing but measured in terms of length. Oh, perfect. Now I know what the answer is. The length is increased 4 times unit wise. Force is also increased 4 times. So what will happen to work? It will become 4 into 4 times, which means the energy will become 16 times. Hence, the answer is 16 times. Hence, the answer is increased 16 times. Is that clear? Option C for Captain Shreyas. Correct. Very good. Excellent. Perfect. Moving on to the next and the last application. Remember, 3 applications were there for dimensions. First one we just did. What was the first one? First one was basically to check the dimensional consistency, and mathematical inconsistency and all of that. Okay. Second one was, first one, by the way, was also used to eliminate options. Second one was to convert from one unit to other, like joule, dyne, centimeter, whatever you want to convert. Last one is to get a relationship between the physical quantities. Observe what it is. Say, for example, you know some physical quantity, basically that it depends on, depends on some other physical quantities, okay? You know that it depends on other physical quantities. Then you can get the relationship between these two in a very simple form without maybe not knowing the constants, okay? And that is what this application is. You can get that this physical quantity is going to depend on, that means it will be equal to some constant could be there, that is okay, but it will be some physical quantity raised to, let's say, x, physical quantity raised to y, physical quantity raised to z, and so on and so forth. But there could always be a constant whose value I do not know, okay? But it will be in this form, and I can get this form and these values of x, y, z using dimensional analysis. This is what the third application is. If I know kinetic energy depends on mass, speed, and something, I can get that formula. If I know viscosity depends on this and this and this, I can get the formula. But if I do not know what it depends on, I cannot do it, number one. I can also not get it if by chance you can't use this method, can't use this method when, number one, the formula has an addition or subtraction. Example for that, V is equal to U plus AT. I can't do that. I can't use this formula. I can't use it for S is equal to UT plus half AT square. When there is plus or minus, I cannot use it. Another time where I cannot use it, when there is exponents or trigonometric ratio or logarithms, or any other complex function, or any other complex function. Example, say loudness is a 10 log I by I naught. I cannot use this method to find this formula. Or let's say the charge on a capacitor is capital Q e to the power minus t by RC. I cannot use this formula. Or say for example, the velocity in SHM is a omega cos omega t. There is trigonometry. I cannot use in these cases this particular method. I cannot use it in this particular method. Also, I cannot use if the constant is, if the constant is dimension, is having dimensions, is having dimensions that we are unaware about, that we are unaware about. Very, very important. This constant which is there, if I don't know what is its dimensions, or this constant is completely unknown, I cannot use this method. But if I know this constant is also having a dimension, this is the dimension, or this is a dimensionless quantity, then I can use it. Either it is dimensionless, or I know what is the dimension. Only then I can use it. If I am completely unaware of what it is, I cannot use this particular method. I cannot use this particular method. Keep this in mind. Also keep in mind some additional pointers. Whenever I have sine or cos or tan, etc., and there is something inside, whatever is there inside is always dimensionless, is always going to be dimensionless. Very, very important. Not just that, whenever I find e raised to something, e raised to something, or let's say log of something, whatever is there inside, understand it is again dimensionless. This also, understand, is basically dimensionless. Whatever is there inside is always going to be dimensionless. So logarithmic, exponential, sine, cos, tan of inside term, all these are dimensionless entities. Not just that, even this sine or log or cos or anything is also dimensionless. Keep that in mind. So if I find the sine or the log or the e raised to something, etc., all these quantities dimensions, all these quantities dimensions, if I find the dimensions of this, dimensions of this, dimensions of this, it is dimensionless. This is dimensionless. This is dimensionless. These are some basic things which you should be very well aware of. You should be very well aware of. Okay, inside also, outside also, they are all dimensionless. Let's understand how to use this method. You should also remember these are the things which, if valid, you cannot use this method. What is that method? Let's understand. Say for example, we take the NCERT question only, and it says that there is a simple pendulum and it has some bob attached and it oscillates due to gravity, and it depends on maybe the length of the pendulum, the mass of the bob, and the acceleration due to gravity. What is the time period of the oscillation? So first of all, what is a pendulum? Pendulum is nothing but something like this. There is a bob. This is the bob. This is the string. It is attached over here. This is your hinge. And what this pendulum does, it goes back and forth, back and forth. So for one oscillation, whatever time it takes, the time for one complete back and forth motion is called as the time period. What is it called? The time period. Symbol capital T. And we have to find what is the time period. We have to find what is the time period dependent on, it is given to be dependent on length, mass, and gravity. So what's the formula going to look like? Without using physics, without using any mathematical knowledge, just purely this chapter knowledge of units and dimensions. Let's try to do that. So as per this, the time period is dependent on the length, the mass, and g. This is like P1, P2, P3, P4. This is your physical quantity. So physical quantity depends on other quantities. Hence, I can say this physical quantity of time period is some constant into length raised to x, mass raised to y, g raised to z. Length raised to x, mass raised to y, g raised to z. Okay. So I will equate the dimensions on both sides. Observe what happens. So the dimensions of time period is dimensions of the constant into dimensions of length raised to x, dimensions of mass raised to y, dimensions of acceleration due to gravity raised to z. This is time period, so it will have t raised to 1. Constant is dimensionless, so forget it. This is length, so this will be length raised to 1 only, so length raised to x. Okay, then this is mass, so it is m raised to 1 only, raised to y. This is gravitational acceleration, so length raised to 1, t raised to minus 2, whole thing raised to z. Let's simplify this and see what do we get. So t raised to 1, I can also write it as, actually there are missing dimensions of mass, mass raised to 0, length raised to 0, t raised to 1. So those are the missing dimensions, raised to 0 is 1 only. Here, this is m raised to y. Lengthwise, I will get x plus z. Check this out. X is there here and z is there over here. Time wise, it is only coming once, so minus 2z. So this is what I get on the RHS. This is what I get on the LHS. What is the next step? The next step is comparing the powers. Like for example, you compare the power of m raised to 0 and m raised to y over here. So comparing it, 0 is equal to y. Therefore, y is equal to 0, 100%. Next thing, check the dimensions of time. Check the dimensions of time, very, very easy to check. Left side it is 1, right side it is minus 2z. So z therefore is negative half. That is also done. Now let's check the dimensions of length on LHS and RHS. On the LHS it is 0, on the RHS it is x plus z. X plus z. But z is negative half. But z is negative half. So therefore, what is x? X is basically plus half. X is basically plus half. Perfect. So now that we have got it till here, what was our original equation coming back? Our original equation, C L raised to x, m raised to y, g raised to z, right? So time will be constant into length raised to x. What is x? It is basically half. Mass raised to y, that means mass raised to 0. And acceleration due to gravity raised to z, what is it? Negative half. Negative half. Can I write this as C length raised to half divided by m raised to 0 is 1 only, divided by g raised to half. What is raised to half? It is basically root. So it is root of L by g. So time period is C root. Time period is basically, I can just put it over here, C root of L and root of g together, and this is it. So that is what the formula looks like. Constant into root of L by g. I can't find the constant unless I perform some mathematical derivations or I do it experimentally. Okay, only till this I can find out. Constant has to be found via experiment. This has to be found via experiment or derivation Without that, we cannot do it. That is the answer for this. The actual formula's constant is 2 pi. So actually it is 2 pi root L by g, but we can leave it till here. That's okay. Amazing, right? So this way you can find out anything. Sir, your opinion of taking a drop for J? I have made a special video for taking a drop or not for J on the J English channel. Just check it out. I feel it is worth it also, depending on certain things, else it is not worth it. depending on few things. It depends on your financial condition, depending on your motivation, depending on your current score, depending on what options you are getting now. So many things, it depends what you want to do. So just check out that video, roadmap for JEE droppers. Let's check out this PYQ. Force, velocity, time are fundamental. For mass, what is the unit? Basically, I will rephrase the question for all of you. Can you find me how is mass dependent on force, velocity, and time? That is the real question over here. Whatever question they are given, you rethink in different ways. So now it becomes the third application of your dimensional applications. So mass is some constant into force raised to x, velocity raised to y, time raised to z. That's it. This is now your regular problem, just like what we did over here. Let's try it out. What is the dimensional formula for mass? It is basically m. Constant is completely dimensionless. Force is m raised to 1, L raised to 1, T raised to minus 2, whole raised to x. Velocity is length raised to 1, T raised to minus 1 raised to y. Time. Time is just T raised to 1, whole thing raised to z. Perfect. So other dimensions are gone over here. So it is m raised to 1, L raised to 0, T raised to 0, because anything raised to 0 is 1. Mass is there only one time, so I'll just put it as m raised to x. Length is there here, so x is there, length is there here also, y is there, nothing is there over here. Time is there here, so it is minus 2x, it is there here, so minus y, and then it is plus z. Perfect. Now you just have to compare the powers on both the sides, you will get the answer. Here and here, if you compare, it's the easiest. So 1 is equal to x, therefore x is equal to 1. The next easy thing to do is L raised to 0, I believe. That will be the easiest one. The next easiest one. So 0 will be x plus y, but x is 1. So therefore, y is equal to negative 1. Last is t raised to 0 here, and this term over here. So 0 is equal to minus 2x minus y plus z. So x is basically 1, so it will become minus 2. Y is basically negative 1, so it will become plus 1 plus z, that is 0. So what will z be equal to? Minus 2 plus 1 is minus 1, goes on the other side as plus 1. So z is 1. Perfect. So let's resubstitute it back over here and see what do we exactly get. So mass is constant, force raised to x, x is 1. Velocity raised to y, so v raised to minus 1. Z is 1, so basically time raised to 1. So that is the answer. So dimensionally, if you see, mass is, C had no dimension. So force raised to 1, v raised to minus 1, t raised to plus 1. Which is that answer? F raised to 1, v raised to minus 1, t raised to basically plus 1. That is basically your option number D, I believe. Yes, it's D option. That negative number is there. I think it is not visible so clearly over here. It is not visible. There is minus 1 over here. It is probably not seen. It is also minus 2 here, minus 1, minus. This is minus 1. Maybe it is not seen. Okay, so that was the answer. This slide was not needed. Okay. Yeah, that is the answer for this. Cool. Everybody understood how to apply dimensional analysis formula? Very good. D for Deekshana. Perfect. Perfect. So, my dear warriors, we have come to the end of the class of units and dimensions. We have completed everything in detail with NCERT, with conceptual problems and the NEET or the previous year questions, be it of AIPMT, AFMC, whatever. After attending these classes, solve many questions. In fact, we'll be updating something called as the treasure box, not just the NEET pedia, but also the treasure box. Let me just show you where the treasure box is. Yeah, see right over here in the description box over here, you can see this link. This link is like our complete set of classes. Some old classes are also there, which we conduct in the last 6 months. We have the 10-year PYQs. So you are going to get the PYQs for all the years, NEET, CBSE, physics, chemistry, biology, all the subjects, chemistry classes, physics classes, biology classes. As and when we update the new classes for this particular RNA batch, we will keep on updating it over here also. This link will get updated. You will have whatever notes over here. If anything else is there, PDF, chapter-wise PDF, NCERT solutions, PYQ test, everything will get updated over here. If there is a new class, the new class link will come because the new classes will be even more comprehensive for all of you. Got it? Clear? Loving this, guys? But I want one promise from all of you. See, there will be a lot of noise regarding re-NEET, no re-NEET. It's very simple, guys. There is no question of whether you should study for re-NEET or not. If your marks are less, if your marks are not up to the mark for getting a government college, means above 620, if it is not there, then I don't think you should bank upon re-NEET, justice to be served, this, that. I mean, even if re-NEET happens, what guarantee that you will get above 620 marks, right? That is another thing. If you are getting 580, 590, then yes, maybe in a re-NEET, whether it happens, doesn't happen, maybe there is a chance of improvement. But if re-NEET does not happen, again, then you have to study more because this year the cutoffs are really high. So you need to be really, really thoughtful about this. You need to be practical about this. It's no longer a game of emotions. It's a game about practicality. If you know that I can't get a government college, I can't spend high fees in private college, I can't go abroad, I'm just wasting my time, waiting for the decision from Supreme Court on 8 July, this, that. I feel you should just prepare for NEET 2025 if you are serious about MBBS or, medical sciences. If you are serious, you should just focus on this. You should not even watch any other videos for NEET 2024. It is done. Don't worry about the result. Even if the new result comes, just throw it into the dustbin. It's of no use because all those will be distractions. You just have to focus on what your final goal is. It is MBBS. It is not NEET 24 or NEET 25. It is MBBS. Or you have to become a doctor. You want to become a surgeon. You want to go into the medical sciences. That is the field which you want to excel in. And NEET is merely a pathway. Whether it happens in 24 or in 25, that shouldn't affect you. So focus on what is ahead and ignore the noise. All right. So with this, I want a commitment from all of you. I want a comment from all of you. I will be regular. I'll be regular. I will crack NEET 25. I'll be regular. That's what I want. That commitment from all of you. And I hope you enjoyed the class. Smash the like button. Share it with your friends. Share it with your batchmates who want to prepare for NEET 25. Because this is a channel for you. Remember, this channel wouldn't be there if a lot of students from South India and Northeast wouldn't have demanded, sir, we need a separate channel in English. And we started this first. We are doing this for you. So it's your responsibility that every student from South India, from Northeast, students in so many schools and colleges across India, even in Delhi and even in so many places. I mean, I can take every city's name. Rajasthan, Jammu Kashmir, Maharashtra, so many places who study in English. So many students who study abroad in UAE, Saudi, America, so many places where people write NEET. They want to enter into the medical colleges in India too. They are serious about studying English. So you need to let them know about this particular channel. Thank you so much. Captain Shreyas signing off. Hasta la vista.